Hey, sixth grade, I hope everyone's doing well. Today you had to do Module 5, Lesson 19. And before I get into that, I just want to remind you all that we do have a Google Meet session today from 10:30 to 11. And on that meet, we're going to be doing a fun little Kahoot to help you review some of the stuff that you've been doing, along with some fun questions. So I hope to see everybody on there. Once everyone's on, I'll give you like the game pin and everything. So we'll take care of that in the morning. But just wanted to give you all a heads up. I did post in Google Classroom earlier yesterday on Tuesday. You'll be watching this on Wednesday. So I posted on Tuesday. Sorry, the days they get a little mixed up. So yeah, I posted about it on Tuesday to remind everybody. So if you're watching this before we do the Kahoot, this is your reminder. So yeah. All right, let's just get right into the lesson. Again, we did Module 5, Lesson 19, and this was about surface area and volume in the real world. So you had a bunch of word problems. As you can see, I messed up again, which I am the prime example of why we don't do math in pen. But if I do it in pencil, it's kind of hard to see through the camera, so I have to do it in pen, but definitely do it in pencil, so when you make mistakes, you can erase it. So let's just get started. I'm on the first page right now. So we're going to be doing example 1. And example 1 says, Vincent puts logs in the shape of a rectangular prism outside his house. However, it is supposed to snow. And Vincent wants to buy a cover so the logs stay dry. If the pile of logs creates a rectangular prism with these measurements, and then it gave us these measurements right here, I underlined them. And it said that our measurements were 33 centimeters long, 12 centimeters wide, and then 48 centimeters high. So it gave us the dimensions that we need, which is great. And then the question's asking, what is the minimum amount of material needed to cover the pile of logs? So we need to do surface area. So we're going to be using the formula that we used on Monday, which is 2 times the front plus 2 times the side, and then times the top as well. So I just wrote a little note on here, and it just says that the surface area, we're using surface area for this, and the bottom on the ground, it does not count as the cover, to cover the logs, to help it like not get wet from the snow. So the first thing that I did is I just drew out my rectangular prism and I labeled it. So I said that my length was 33 and my width was 12, and then my height was 48 centimeters high. So I went ahead and I labeled my top, my front, and my side. So then I just went ahead, here, let's move this in. I went ahead right here and I did my formula, which I stated in the beginning, and then I started to plug in my numbers. So I did 2 times 33 times 48 plus 2 times 12 times 48 plus 33 times 12. So I went ahead and I did what was in the parentheses first, and then I brought down my 2. Okay, so I did 33 times 48, which gave me 1,584 plus my 2, which I brought down because I want to do what's in my parentheses first, 576, and then plus 396. Okay. So once I got those numbers, I multiplied my 2 to these ones. This one could just go right down there. And then I got these 3 numbers right here. And if you just add up those 3 numbers, you get 4,716 centimeters squared as your final answer for that one. So that's how you did that one. Now, for exercise 1, it's asking us to use our knowledge of volume and surface area to answer each problem. So it says Quincy Place wants to add a pool to the neighborhood. When determining the budget, Quincy Place determined that it would also be able to install a baby pool that requires less than 15 cubic feet of water. I underlined this because this was an important piece of information. And then it says Quincy Place has 3 different models of a baby pool to choose from. So it gave me choice 1, 2, and 3, and then it gave me all the dimensions in it. And it says that right there. It gave me all the dimensions, choice 1, 2, and 3. So basically, Quincy Place, if they want to install a baby pool, then it requires less than 15 cubic feet of water. So this means that when we're looking at our answers, it can't be anything higher than 15 cubic feet of water. So what I did for this is I need to find the volume. So let's go all the way back to volume, like what we did in the beginning of the unit. And we know that our formula for that is length times width times height. So that's what I used for choice 1, 2, and 3. So I went ahead, I drew out my pictures. I just drew out the pictures to kind of give me a better visual, but you could have also just used the numbers given to you. But like I said, I like visuals. So here's choice 1, length times width times height. I said my length was 5, my width was 5, and my height was 1. When I multiplied those together, I got 25 feet cubed for choice 1. So obviously 25 is higher than 15, so we know that that is too much water, and we can just X off choice 1. Now for choice 2, I did V equals length times width times height, and then I said V equals my length, which is 4, my width, which is 3, and my height, which is 1. If you do 4 times 3 times 1, you should get 12 feet cubed. So, okay, we know that that's less than 15, so that could potentially work, but I'm not going to jump yet because I want to go to choice 3 and see what I get for this. So now choice 3, I did the same thing. I used my formula, V equals length times width times height, and then I just did V equals my length of 4, my width of 2, and then my height of 2. And when you multiply those together, you get 16 feet cubed. So 16 is obviously bigger than 15, so that's going to be too much water as well. So I went with choice 2. That is my winner. Those are the dimensions of the baby pool that they need to install. So that was that one. Now, on the next page, number 2 says, a packaging firm has been hired to create a box for baby blocks. The firm was hired because it could save money by creating a box using the least amount of material. The packaging firm knows that the volume of the box must be 18 centimeters squared. So here's another one. I underlined it right here. Just some information. We know that the volume of the box needs to be 18 centimeters cubed. So for A, it's asking us to list all the possible dimensions for the box if the volume must be exactly 18 centimeters squared. So all you had to do here was just find different examples of multiples of 18. So think to yourself, okay, what times what equals 18, okay? So I got 4 different things for this. So I just labeled them A, B, C, and D, and then I just used the formula length times width times height since we are doing volume, and that is the formula for volume. So for A, I started with this. I said, okay, 18, what times what can give me 18? So I said 18 times 1 times 1. And then for B, I said 9 times 2, which is 18, times 1 is going to stay 18. C, I did 6 times 3 times 1, which gave me 18. And then for D, I did 3 times 3, which is 9, times 2, which is 18. So for this one, all you wanted to do was just see how many multiples of 18 you could find, if that makes sense. I don't know if I'm saying that right. It sounds weird saying it. But yeah, you just want to look at 18 and say, okay, what times what equals 18? And think of all the multiples of 18 and then list them. So that was 2A. Now 2B is going to make us take all of those dimensions that we just listed out right here, and it's going to make us find the surface area of A, B, C, and D. So this one was kind of a little bit longer to do, but you're just going to be using the same formula that you used right here. So you're going to be using the same formula that you've been using, which is good. A little repetition in there for you. So B says, which set of dimensions should the packaging firm choose in order to use the least amount of material explained? So we are using surface area for this. So all that I did was I did A, B, C, and D. And I just did my formula for that I did for everything. I'm not going to go through every single one because it does get a bit repetitive, and I doubt that you want to hear that, but I will go over A. So say for A, I'm looking up here at A. So I know that I have 1, 1, and 18. So I did 2 times 1 times 1 plus 2 times 1 times 18 plus 2 times 1 times 18. So like I said, I did what was in parentheses first. So 1 times 1 is 1. 1 times 18 is 18. 1 times 18 is 18. And then I brought down my 2's. I multiplied my 2's to those. So 2 times 1, 2 times 18, 2 times 18. And then all I have left is my plus sign. So I have 2 plus 36 plus 36. And that gave me 74 centimeters squared. Okay, so the question is asking which packaging, which set of dimensions should they use that in order to have like the least amount of material. So when you do this one, you want to look at what your lowest number is. So I got, let's see, I got 74 for this one. This one's kind of squeezed in there, but it's 54. And this one's 58, and this one is 42. So obviously 42 is the lowest number out of all of those surface areas. So that's what I did. And then for B, C, and D, I literally just did the same thing as I did in A. I took my numbers from up here and I just plugged them in. I did the same math that I did in A. And that's how I got those answers. And at the end, I looked at what my lowest number was, which was 42. And that's how I got my answer. So that was that one. And then for 3, it says a gift has the dimensions of 50 centimeters by 35 centimeters by 5 centimeters. You have wrapping paper with the dimensions of 75 by 60 centimeters. Do you have enough wrapping paper to wrap the gift? Why or why not? So the first thing that I did was I said, okay, I have wrapping paper and the dimensions are 75 by 60. So I took those two numbers and I multiplied them together and I got 4,500 centimeters squared. Okay, so that was kind of how much I had total. So now when I do the math, I need to make sure that the number that I get does not exceed that 4,500. And I just did this by doing surface area. So again, I did exactly what I did for this problem and this one right here. So I drew out my box. It gave me the dimensions. It said 50 was the length, and then the width was 35, and the height was 5. So I went ahead, I plugged those numbers into my formula, and I got 4,350 centimeters squared. And obviously that number does not exceed this one down here. So yes, I do have enough wrapping paper. So that was your little explanation for that. And then for 4, the last one, it says, Tony bought a flat rate box from the post office to send a gift to his mother for Mother's Day. The dimensions of the medium-sized box are 14 inches by 12 inches by 3.5 inches. What is the volume of the largest gift he can send his mother? So for this one, literally all you had to do was use the formula, V equals length times width times height. I forgot to write it. So it literally gave me the dimensions. So it gave me my 14, my 12, and my 3.5 right here. So all you have to do was plug these 3 numbers into the formula. So 14 times 15 times 3.5. And when you multiply those 3 numbers together, you should get 588 inches cubed. Remember that I know we keep on going between volume and surface area. Your labels for volume are always going to be cubed, and then for surface area, they're going to be squared. So remember that. Try not to get too confused. I know it can get a bit confusing with all the formulas, but yeah. So that was your lesson for today. Keep up the good work. You're all doing great, and I hope to see you all on the Google Meet. So yeah, I will see you all very soon. Have a great day.